All right, guys, welcome to lesson 5.09. We're going to be working with similar right triangles. Remember, similar figures have corresponding angles that are congruent and corresponding sides that are proportional. And we also always need to pay attention to our mapping because it tells us that the angle A corresponds to angle D, B corresponds to angle E, and C corresponds to angle F. I know those angles are congruent. And because I know that my corresponding sides are proportional, I can set up a proportion. I will call this one my little one and my big. All I have to do is I can do either little over big equals little over big, or I can choose to take the big one first over something little, or big over little, or I could do like short side over long side equals short side over long side. I just have to keep the pattern the same. All right, so go ahead and set yours up. I'm going to set mine up. 8 corresponds to 12. Those are my short sides. And then 20 corresponds to x. Cross multiply and divide. Find out that x equals 30 units. Okay, let's recall the parts of a right triangle. The hypotenuse is always the longest side, and your angle marking kind of points towards it. The other two sides, you'll have a short leg and a long leg, unless it's an isosceles right triangle. Then the legs would be congruent. Okay, sometimes we have situations like this where someone's drawn an altitude from the vertex of the big triangle perpendicular to the opposite base. And now I got 3 right triangles. I got this smaller one, this medium-sized one, and then the large one, which is all the way around the outside. They're all going to be similar to each other. Now remember, the mapping matters. So if I was going to make a similarity statement here, I would say that triangle ABC is similar to triangle, and one thing I like to do is match up my right angles. So I've got my right angle situated there, so I don't have to say angle ACD because that's one of my right angles. And I've got my short sides and my long sides corresponding. So that would be my similarity statement. Okay, using that, I'm going to carry that over to the next page. We're going to set up some proportions here. I am looking at BD. This is on my small triangle. And then I've got CD, which is on my medium triangle, is equal to, I go back to my small triangle and go CD, and then I go to my medium, which is going to be AD. AD is in the same position on the medium triangle. When I'm looking at AB here, AB is in line with my large over CB, which is my small. So I'm going back to the large, and it's CB backwards this way, so I'm going to go to the small and go the same way and choose DB. I'm looking again here at AB for my large. And then I go to AC, which is my medium. So I'm looking at AD, that would have to be for my medium, the last two, the first and the last. So I go back to my large, and I pick the first and the last, and that's where I get the AC from. Keeping your pattern the same. Okay, so we're going to solve for X. One of the strategies I always do before I start these problems is I break out my triangles, small, medium, and large. And then I go ahead, I've given myself this point D right here so that I can have that as a vertex labeled. Now I can look at all my triangles separately, and it becomes a lot easier to set up my proportions. When I'm looking at this, I can say, oh, okay, that X corresponds to the 12. I can set that equal to, X was on the small one, so I'm going to go back to the small one and get the 12. It corresponds to the 16. Then I can just simply cross multiply and I get 16x is equal to 144. So x equals 9 units. Really helps to break those triangles out. Here's another example. Once again, I've taken my overlapping 3 triangles, and I've got my small, my medium, and my large. I gave myself that point D so I could look at things. Notice they're over here on my triangles. And then I just kind of match up things with long legs, short legs, and hypotenuse so I can get things labeled. Now it's going to be so much easier for me to set up my proportion to solve for x. I'm looking at my medium and my large triangles. So that 20 corresponds to the 25. Go back to my medium, corresponds to 20. Cross multiply. Divide by 25. And x equals 16 units. Okay, let's look at this number 1 together here. Once again, small, medium, large. Giving myself this point D here that I have put onto the triangles. And then I just match up, like for my small one, that was my short side was 3, my long side was x. I'm looking at the medium triangle. My short side is x, my long side is 12. I don't know the hypotenuse, so it's not there. And then I'm looking at my big triangle. I know the hypotenuse is this whole thing, so that's 15, but I don't know anything else. So then I got to solve for x, and I'm looking at this 3 corresponds to this x. 3 to x. And then this x corresponds to this 12. That's where I get my x to 12. Cross multiply, x squared equals 36. Take the square root of both sides. I find out that x equals 6 units. Pause the video. I want you to try number 2. Try drawing your 3 different triangles and see how you do. Did you find out that it was the medium one and the large one that you would use? Okay, what I have next for you is these. You've got 1 through 9. Number 9's a little proof, and there's a little error in it here. This should say EC instead of ED. But other than that, it should be fine. And I want you to go ahead. This would be good practice for checking if you can do your 3 triangles. Identify which ones you use, and use your proportions to solve. Since the sides are proportional, you can use a proportion to solve. The key is on the next page. I'll let you get to that. So pause your video. Here's the key for 1 through 6, showing my work. And here's the key 7 through 9. Showing my work. Feel free to pause and look through these things. Make sure you're getting them right. As always, if you have any questions, hit me up on It's Learning or bring them to me in class. And have a good night, and I'll catch you at the next lesson. Bye.